The James Webb Telescope has just unveiled the clearest image of Proxima b in history, revealing astonishing details about this potentially habitable exoplanet. Join us as we embark on a journey through space to uncover the mysteries of Proxima b and discover whether it could be the next Earth. Let's take off to the exciting exoplanet in the vast expanse of space. A mysterious planet exists in the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock. It's Earth's cousin, Proxima Centauri b, located a mere 4.2 light-years away from us, is shrouded in mystery and wonder. Could it be another Earth, with oceans and life teeming on its surface? But wait, there's more. Proxima Centauri b is not alone in its journey around the red dwarf star. It has a fellow traveler, the super-Earth Proxima Centauri c, and who knows what other secrets this star system holds. Perhaps there is another companion that we have yet to discover. And the mysteries don't stop there. Proxima Centauri b receives just about the same amount of energy from its star as Earth does from the Sun. Could this mean that there's water on its surface, perhaps even life? As we venture beyond our own solar system, we discover a whole new world of exoplanets. Planets that orbit stars other than the Sun. With 206 billion stars in the universe, the possibilities of exoplanets are endless. Some exoplanets even roam free, untethered to any star, like rogue travelers in space. But among them all, Proxima Centauri b stands out as a truly remarkable and enigmatic planet, with a year that lasts just 112 Earth days. Its distance from its star is 20 times closer than Earth is to the Sun, making it likely that one side of the planet is always bathed in daylight, while the other side remains in perpetual darkness. Let's talk about Proxima Centauri b, the star that orbits the red dwarf Proxima Centauri and forms part of the Alpha Centauri triple star system. This system is made up of Rigil Kentaurus, Alpha Centauri A, Ptolemy, Alpha Centauri b, and Proxima Centauri, Alpha Centauri c, creating the nearest star system to our very own solar system. The two stars, Rigil Kentaurus and Ptolemy, form the binary system known as Alpha Centauri AB. These G and K-type stars appear as one star in the constellation of Centaurus and are the third brightest stars in our night sky, with a peak amplitude of -0.27. Now, let's turn our attention to Proxima Centauri, also known as Alpha Centauri c. This red dwarf, or M-type star, is located 0.21 light-years away from the other two stars, which is approximately 13 times the distance between Earth and the Sun. And get this, it is technically the nearest star to us. In fact, Proxima Centauri translates to the nearest star of Centaurus in Latin, and it was discovered in 1915 by Scottish astronomer Robert Thorburn Innes. Despite being our nearest stellar neighbor, we can't see it with our bare eyes, as it has an apparent magnitude of 11.13, which is far greater than the maximum human eye limit of 6.5. But don't let that fool you. Proxima Centauri is still a star worth marveling at. Red dwarf stars like Proxima Centauri are among the most efficient in terms of energy production. They may not generate a lot of energy, but the internal convection process at their core keeps them glowing for trillions of years. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still being debated. For one thing, it's a flare star, meaning it has frequent and unpredictable fluctuations. As a low-mass star, the habitable zone would be closer to it than that of the Sun. It is projected to be between 0.23 and 0.054 Australian dollars, but it may not be as habitable as it seems. While it might appear to be a promising planet, don't let its appearance deceive you. Sure, it's at the same distance from its star as Earth is from the Sun, but that's not the whole story. Proxima b is bombarded by extreme ultraviolet radiation from its Sun, hundreds of times stronger than the radiation we get from our own Sunday. That's right. It's so intense that even the lightest molecules of hydrogen get destroyed, let alone nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima b might not have a suitable atmosphere, which is essential for regulating climate and supporting a water-friendly surface. Without it, living organisms would be vulnerable to dangerous space weather, making life nearly impossible. While there are numerous factors that render Proxima b unlivable, the quest to uncover the truth about it continues, and some people still have hope. One instrument that has captured the attention of astronomers is the James Webb Space Telescope. After numerous delays, the telescope was finally launched in 2018, and it will help us determine whether or not there is life on Proxima b. As with all things in science, things are never quite as straightforward as they seem. Many modifications were required to ensure the James Webb Telescope produced accurate images. As theoretical physicist Loeb at Harvard explains, if a planet like Proxima b can absorb light from its star, it can also re-emit it as infrared light. The James Webb Telescope was specifically designed to observe infrared light. It can take photos of this light on the surface of the planet and look for patterns that could confirm whether the planet has water or an atmosphere. But what if the planet has an atmosphere that is not conducive to life? The presence of an atmosphere does not guarantee the presence of life, warns astrophysicist Ed Turner at Princeton University. Proxima b could be like Venus, with a thick atmosphere that is 90 times denser than that of Earth and extreme heat that would make it impossible for life to exist. The quest to unravel the mysteries of Proxima b is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, astronomers are hard-pressed to find a way to observe planets like Proxima b. The risks are great, but the rewards are even greater. The chance to glimpse into the unknown and uncover the secrets of a distant planet that holds the promise of life. It's a journey that astronomers are willing to take. Let's imagine, hypothetically, that Proxima b is hospitable. Could we even go there? It's the closest exoplanet to us, which makes it so exciting because it's almost like looking in our cosmic backyard. What's even more interesting is that it's roughly the same size as Earth, and its location in the habitable zone means it could potentially have the conditions for life as we know it. Proxima b's proximity also makes it a prime target for our search for life beyond Earth. With it being just around the corner, well, relatively speaking, it's a great contender for interstellar missions. Imagine the possibility of exploring this Earth-like exoplanet. Though we can't travel there yet, it's definitely on the radar for future missions. As technology advances, it remains one of the most exciting projects in the field of space exploration. But getting there is no easy feat. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. However, a solution has been proposed: solar sails. These ultra-thin sails could be used to accelerate a spacecraft to the Alpha Centauri system, and Proxima b along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the issue of running out of fuel. With expected speeds of 10 to 20% of the speed of light, the journey to the Alpha Centauri system could be reduced to just 20 years. The discovery of Proxima b has reignited humanity's fascination with space exploration. It has given us a newfound sense of hope that we are not alone in the universe. The James Webb Telescope, a marvel of modern technology, has the power to take us all the way back to the very beginning of the universe, 13.7 billion years ago. Here's how it works. The farther away an object is, the longer it takes for light to travel from it to us. This means the James Webb Telescope can actually see objects in the universe that are farther away than any other telescope before it. Plus, it has the capacity to observe these objects in longer wavelengths of infrared light, which means we can see even more distant stars with greater clarity than before. And you know what's even cooler? This incredible technology has the power to shed light on the possibility of life on other planets like Proxima b. But as with anything this awesome, there are limitations. For example, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima b could be like Venus, with a thick, hot atmosphere that's not suitable for life. And get this, the James Webb Telescope has the power to detect such illumination if it reaches a brightness of just 5% of the natural dayside. 5% might not sound like much, but when you're dealing with a star that's 20,000 times dimmer than our own sun, it's actually a huge deal. If Proxima b does have an intelligent civilization lighting up its surface, they may be using bright orbital mirrors to reflect sunlight from the day side of the planet to the night side. How cool is that? There are countless exoplanets waiting to be discovered. In our universe, these planets come in all shapes and sizes, with some being massive gas giants, while others resemble our very own Earth. But what do we know about them? One type of exoplanet that has captured the attention of astronomers is the gas giants. These planets are similar in composition to Jupiter and Saturn, but they are much larger. Some of these behemoths have been dubbed superjupiters, and they dwarf even the largest planet in our solar system. But that's not all. There are also hot Jupiters, which are gas giants that orbit extremely close to their host star. They exist in a fiery world with temperatures that could melt metal. Imagine being able to witness such a planet up close, with its raging storms and blistering heat. In addition to gas giants, there are also Neptunian exoplanets, which have sizes similar to Uranus and Neptune. Among these are the hot Neptunes and mini-Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being difficult to study from afar. Let's not forget about the terrestrial exoplanets, which resemble our own planet Earth. These planets come in various sizes, ranging from smaller than our world to double its radius. There are even super-Earths, which have masses greater than twice that of our planet but are lighter than Neptune. One of the most intriguing exoplanets in recent years is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth, with an approximate mass of 7 Earth masses. Although it is close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri b is not alone. It has a partner in crime, Proxima Centauri c, which is even further away from the star. This planet has an orbital period of approximately 5.5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more fascinating about Proxima c is that it appears to be a very bright world, possibly due to the presence of a ring system. And there's still more to discover in the Proxima Centauri system. In 2019, astronomers detected a change in the star's radial velocity, which could be the result of another planetary partner. If confirmed, this planet will be known as Proxima Centauri d, and it will be roughly the size of Mercury or Mars. Imagine a world where the night sky is filled with not just stars, but countless other planets, each with its unique composition and orbit. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made all the time, it's an exciting time to be an astronomer. While we don't yet have an accurate count of exoplanets, we do know that they exist, just like the stars that light up the cosmos. However, exoplanets are not easily observable, and it requires state-of-the-art technology and powerful telescopes to detect them. These planets are often obscured by the glare of their host stars, making them difficult to study. But with advancements in technology, direct imaging of exoplanets is now possible with some of the world's largest telescopes. To be directly imaged, an exoplanet must be large enough to be seen by the telescope, far enough from its host star not to be obscured by its glare, and young enough to be hot and visible from Earth. These requirements limit the number of exoplanets that can be directly imaged, but they provide a fascinating glimpse into the characteristics and composition of these distant worlds. Exoplanets are most commonly discovered through the changes they cause in their host stars. The gravitational influence of an exoplanet can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. The exploration of exoplanets has opened up a whole new frontier in our understanding of the universe. With the advent of powerful space telescopes like the James Webb Space Telescope and the Kepler Space Telescope, astronomers are now able to detect and study planets light years away in unprecedented detail. These missions have provided us with new insights into the diversity of planetary systems that exist across the cosmos. From gas giants that are larger than Jupiter to rocky worlds that resemble Earth, every discovery deepens the mystery of what lies beyond our solar system. One of the most exciting aspects of exoplanet research is the potential for discovering habitable worlds, planets that could support life as we know it. To date, more than 5,000 exoplanets have been confirmed, with a growing number being identified in the habitable zone, the region around a star where liquid water could exist on the surface of a planet. The habitable zone varies depending on the size and temperature of the host star, but it is an area where life-friendly conditions might emerge. Proxima Centauri b is one of the most promising candidates because it lies within this zone. although scientists are still debating whether its conditions could actually support life. As technology improves, the methods used to study exoplanets are becoming more sophisticated. For example, the transit method, one of the most successful techniques for detecting exoplanets, involves measuring the dimming of a star's light as a planet passes in front of it. This technique allows scientists to determine the size, orbit, and composition of the planet. In some cases, scientists have even been able to detect the atmosphere of an exoplanet by analyzing the way light from the star filters through it. These studies can give us crucial information about the chemical makeup of distant planets and their potential for supporting life. Another fascinating aspect of exoplanetary research is the discovery of planets in binary star systems, where two stars orbit each other. These systems are thought to be more common than previously believed, and they may present unique conditions for planetary formation. Some exoplanets found in these systems might experience unusual climates, having two suns in their skies and potentially even two habitable zones. Such planets may offer intriguing possibilities for future exploration. Beyond just studying individual exoplanets, astronomers are increasingly focusing on entire planetary systems. Some systems feature planets that orbit their star in ways that are vastly different from what we see in our own solar system. For example, hot Jupiters are gas giants that orbit their stars at incredibly close distances, resulting in extreme temperatures that can melt metals. Understanding these extreme environments helps scientists learn more about the formation and evolution of planetary systems in general. In addition to technological advances in observation, future space missions may involve sending probes or even landers to distant exoplanets. Although the challenges of interstellar travel are immense, some proposals have been made for using innovative propulsion technologies, like ion engines or laser-powered sails, to explore nearby stars and their planets. These missions would not only expand our understanding of distant worlds, but also push the boundaries of human exploration. The search for habitable exoplanets is one of the most profound scientific endeavors of our time. Each discovery adds to the possibility that we are not alone in the universe, inspiring future generations of scientists and explorers to continue venturing farther into the cosmos. Whether or not we ever find a second Earth, the search itself is bound to yield groundbreaking insights into the nature of life, the formation of planets, and the vastness of the universe.